Hi, folks. Welcome to the next session at DSS. In this session, we have Kevin from New Black, who will be speaking about modern commerce is omnichannel and borderless and built on distributed SQL. Kevin, over to you.
Hello, everybody. Thanks for the introduction. So my name is Kevin. I'm here for New Black, and I'm going to be presenting you about the application we call Eva and how we went through our journey moving from one database over to Yugabyte DB. So a little bit about New Black, what we do. We focus on billion-dollar retailers, and we're helping them onboard themselves to something we call contextual commerce and omnichannel, and essentially helping them provide both online and offline to be a seamless experience, so there's no gaps in between. So some of our customers that we work with, Rituals, Burberry, Dyson, G-Star, and Phoenix, all very big retailers in this case, running multiple hundreds of stores across different countries all over the globe. So that's where you can see that having a global presence with an application is something that's very important to us. Many transactions running to the platform, especially during end of year. And we also work together with strategic partners, one of the bigger ones being Apple and Microsoft. And I'll talk a bit about that later. So Eva, our platform, our bread and butter, so to say, is our application. Eva split into different parts. We have a backend system. There's front ends running on that, and then we also have the custom integrations that integration parties make or our customers actually develop themselves up on our platform. So as I said before, what we offer is one solution fits all for both on and offline. So we have our apps onboarding on the same API as well as those integrations. So a brief overview of our setup and all the features that we offer. So social commerce, we offer an app that's developed externally for the consumer. So in this case, like a website, but then fit into an app. We have a CFD, which is in-store, which talks to our POS, which you can see all the way on the left side. We offer the app suite, which is a native iOS app that the employees use in the store. A bit about that more in detail later. And then also BI for customers to have real insights into the transactions flowing through the platform. So a brief overview of the apps that we offer. We have the suite, which is where you do all your management. This is usually used by HQ, for example, to manage the stores, customer support to help through orders, and to have insights into the application, managing discounts, managing products, all that kind of stuff. Then our apps that are used in store, so POS and the native iPhone app. So here you can see a short overview of the suite in this case, where you can see the different modules being accessed to help employees in store and as well as customers. Then the app suite, our native app, split into 3 different apps. In this case, we have on the left side the loyalty app, where you manage all your customers and your onboarding of customers. Then the checkout app, especially focused for helping customers actually check out and leave the store with the products. And then a task app to help employees in store to perform all the logistical tasks, among others, in the store themselves. All right, so taking you through our architecture from top to bottom, we have our front ends, in this case the iOS apps and the web apps, one being the apps that run in store, then the suite being the web app, but also custom integrations from our clients, for example, that make their own apps based on our API. And that takes you to the next one, are SDKs, which we offer for TypeScript and as well as Swift. This is used for easier integration and just keeping up with the different changes that we make to our API. Moving down one layer, you have the Eva API layer. That's essentially the thing that we worry about, is the backend where we expose everything that you can do within Eva. Then if we move one down, you have all of the different functionalities that we offer through that API. Then moving one down again, we have our technology stack. So different components needed to be able to host and run Eva. And of course, the database being one very important part, but we'll talk about that in a bit more detail later. And then moving down to the last layer, our platform is hosted in Kubernetes. Everything's neatly running in pods and containers, so it's easy to scale up and down whenever we want to. Then I'll take you through the current situation of our application. So what we have is we're running on AKS in Azure. We have a load balancer in front of everything. So all the requests coming in are routed to our API pods. Those handle the request and then spit them back out. And you can see that we have EVA plotted 3 times in this diagram. Is because we split up our application into different profiles, purely running the API requests, then one specifically running our messages, which are handled through Rabbit and Kafka, and then we have one specific one for the tasks, which run every scheduled task every now and then for recalculation of prices or for exposing the feeds that we generate, so data from EVA can be consumed by other parties. Then we have Elasticsearch as well at the bottom, which we use for searching through our orders, products, users, stock mutations, among others. Then we have Redis, which we use for locking as well as caching and inter-server communication through POP and SUP. And then at the bottom, currently we are running on Azure SQL to make sure all the data is stored and can be served again. So having used Azure SQL for quite some time now and lots of data having been loaded into Azure SQL as well, we are running into some limits. One of the biggest things that we're running into is essentially scalability. So there's only so much cores that we can scale towards, and there's only that one machine essentially where Azure SQL is running on, which also kind of bubbles down into the other 2 key points of why it's not working for us anymore. One of the things about scalability that we're running into is, as I said, we're an omnichannel platform, so we do both on and offline, and we try to bring that together. So one of the things, for example, if our customer has a consumer app or they integrate their website onto our API, what happens is when you have these launches with newsletters, you can get quite a big peak in traffic. And that means your database has to be up to the task as well. So we can scale our application like as big as we want to, of course, just essentially add more VMs, more containers, and it'll run. But you're still stuck with that one bottleneck at like the very back end of it, which is your database essentially. So at some point there will be no more cores for us to add, no more memory to add, but it will just slow down all the requests that are incoming. So that's one of the biggest issues that we're seeing that we're running into as we move more and more towards the future where we're onboarding more and more for online channels as well for customers. Then one of the bigger things, resiliency. Because we're also running store operations, meaning if our database would be down or have a hiccup or any kind of slowing down, so maybe even like taking the previous scenario into account, there's a huge spike because of a newsletter, the database doesn't pull it anymore or has even maybe outage. That means the stores are essentially down as well because there's no database backing it anymore. And that's a huge problem for us because we don't want our customers to suffer any downtime because store operations always have to keep going. Just imagine you sitting behind the desk and having to wait like up to a minute for a transaction to go through or a receipt being printed in a store. That's not something we can sell to our customers. Then another key point, global low latency. Right now we're essentially tied to a single region, which means if we have a customer that's running in Japan, that's already a huge latency hit. We can host our application there. That would kind of bring the pain down a little bit, but we still have to make those round trips back and forth to the database that might be running in Europe, which is a big latency hit that we also don't want to have for our customers. We've tried other solutions before to try and scale our application globally, but those didn't work out for us, and I'll get into some of the details about why that was. So the 2 databases that we tried before were CockroachDB and CosmosDB. So CosmosDB, of course, being a Microsoft product, and then CockroachDB being more of a rogue agent in this case. The thing with Cockroach was they were not compatible enough with Postgres, so we had issues there with the syntax. And then there were all other things like missing functions, triggers, and custom types that we're running into. And we also had some doubts with it being written from scratch versus something that's a proven technology, like a database that's already running on Postgres, taking GigabyteDB, for example. Then Cosmos DB, whole nother ball game. It was NoSQL, of course, but the way that's set up with the documents, it didn't work out for us. Then another blocker was that we couldn't have those asset transactions that we wanted to have, with the peace of mind and knowing that the order that you actually write into the database is actually the order that's being written to the database and not being overridden by some other process. And then the hot partition key was problem was also something that posed a problem to us. So talking about the future architecture and where we're moving with EVA going forwards, of course, changing the database sounds easy, but of course we're running a platform with 9 terabytes of data, processing a lot of queries per second. We can't afford any downtime, so swapping out the database is not as easy for us as it used to be. And we're moving towards a whole new model where we're trying to host our application across the globe, spread across the globe, not necessarily having all the API pods, for example, running in one region, but multiple regions, and essentially trying to get that same sort of outage that we can have with GigabyteDB with our own application. So maybe if a single region fails, we can still work in the other region. One of the big things that's going to be helping us there is our new hub and spoke setup. It's where we're essentially dividing our whole Kubernetes cluster across the globe. So that's something really cool that we're working on. And this also brings the opportunity to actually like hook into the full power of Gigabyte, also being scaled globally, besides our pods also being scaled globally. One of the big challenges though for us is the whole locking mechanism. So right now we're very fond of having a lock, for example, for the order or a payment transaction, wait till we have that one, and then actually make mutations to the data model just to ensure that the data is consistent. So that's one of the challenges that we still have to resolve. And one of the other things that this brings to us is that we can also start scaling Kafka across the globe. So we can also geo-replicate that, use that for more inter-server communication. So this is something really cool. And also what this brings us, now that we're not dependent on Azure SQL anymore, is that we're essentially also becoming one step closer towards cloud agnostic. It's not a goal per se, but it's nice, a nice thing that also comes with this whole addition of changing out the database as well. So some of the things that we have to deal with while swapping out the database and all the things that come with running a platform as EVA. We have an SLA of 99.99% with our customers. So essentially this drills down to you don't want to have any downtime on a yearly basis. The reason why this is so important for us is, like I said before, is just imagine yourself standing behind the counter as an employee in the store, performing a transaction, and then having to wait up to a minute or maybe even 30 seconds. Just start a clock, wait. It's ages if you're having to wait with a customer behind that desk. So that's why uptime for us is such an important thing, and also low latency. So that brings me to the next step about geo distribution. Uptime is one thing, but we also want to guarantee that the transaction that's being handled is handled fast. So because we're an omnichannel platform, both on and offline, if you're on a website, you want that product to be in your basket fast. You want to be able to pay fast. Everything has to be smooth. The same goes for in-store. It might even be more important in-store, because you don't want the employee to be frustrated, you don't want the customer to be frustrated, and the transaction just has to flow as smoothly as possible. Then one of the things for us is that we're processing 20,000 queries per second at any given point in time, and then during the end of year season, this might even be pushed further up. And one of the fun things as well is while we'll be performing the swapping out of a database, is we would still be performing these kinds of queries per second while trying to swap out Azure SQL for GigabyteDB. So that's also a challenge on our end. Then, as I mentioned before, most important season, end of year. This is where retailers make essentially the most amount of money. So if there's any downtime at all here, it's very bad. So as stated in the next point, if there's a minute of downtime, this can literally cost them like millions, because if we have a hiccup, it's not just one store that has a problem, it's all those stores, right? Globally. So having that uptime is crucial, it's key. So moving over to data migration, on how we're going to be moving everything that we have now in Azure SQL over to GigabyteDB. One of the biggest things for us is that we have to make a breaking change to our API. Right now, we're exposing all of our identifiers as 32-bit integers, as well as a numeric type in our JSON API. So that poses a challenge when moving to larger numbers, because in JavaScript, you're limited to those 51 bits, and anything besides that will just overflow. So we're smoothly transitioning this in, where with the first customer that we're going to be bringing live, we'll be limited to 51 bits of size for identifiers. And the breaking change that we're trying to push towards our clients and integration parties is to actually treat the IDs that we expose as strings. So we can lose the whole discussion about does the number fit into the identifier in this case. And this also opens up the next opportunity is to move towards 128 bits identifiers, which is essentially UIDs, but we're talking 2026, 2027 when we're having it about this topic. The way we did or are currently in the midst of performing the data migration from Azure SQL over to Yugabyte DB is by using something called Azure Data Factory. The reason why we chose this instead of a custom script is because it was faster for us to get going and to start like proof of concepting with if it even works or not, instead of starting from scratch writing code for it. And it's been panning out quite nicely for us. Together with the guys from Yugabyte, we had a very intense work together, and we actually we started out with separate inserts. Of course, those were not fast enough because they were all separate transactions. Moved towards multi-valued inserts, still proved not fast enough for all the data that we have to move. And then at the end, stopped at the copy command because that was something we could also do. At first we thought it was a limitation of Azure Data Factory, but it proved not to be. The copy command was working really fast. We moved gigabytes of data in minutes. And when we're talking about moving 9 terabytes of data, speed is also a really important factor to try and limit our downtime as much as possible when we're gonna be performing the migration. So what we did, we translated 1,500 queries in our code to Postgres syntax essentially, so they work on Yugabyte. 75% of those translations we actually did through AI, because otherwise it would be like too much work for the whole workforce to like essentially stop any other development while doing this. That actually worked out quite well. So 75% worked straight away without any modifications. Of course, there's like tweaks and modifications that you have to make, like to tune that performance, but I'll get into that a bit later. And the other 25% that was left after was done through blood, sweat, and tears. We still had to fix the query, run the integration test suite, see if that test was fixed, and then reiterate for every test that we have to make sure that all those queries actually run on Yugabyte DB. So now talking about our transformation from our infrastructure, we're moving from this model where we have essentially very high over, of course, we have a database bound to a single region, to something that's way cooler, where we have Yugabyte DB as well as our application scaled across the globe, running across the globe, offering low latency essentially everywhere we want to, as well as having the resilience, like having one region go down shouldn't matter anymore, and this is just fantastic. I love to see this. So the currently proposed architecture we're going to be moving with Yugabyte DB initially is the setup that you see here. So we're going to be running RF3 in different regions, of course, and we're going to be starting out with probably somewhere between 12 and 16 CPUs to start out with. But this is very much in concept stage still, because it's we're still load testing to see what works best for our application. So this is very much in the works. So the key milestones that we currently have moving forward. Actually, last quarter we moved over the internal demo environment. So that was cool to get going, so we can get a feeling with how that works with our existing applications, if we're running into anything funky. Then for the upcoming quarter, so this quarter, we're trying to compare the performance that we have right now, comparing that to a setup with Yugabyte DB. We're working together with Yugabyte to see where we can make that, tune those queries and make sure that we even try and surpass our goal that we have. And then we have something called friendly IDs. So the whole breaking change that I talked about, moving from 32-bit IDs over to essentially 64-bit IDs in the near future, We're going to be moving from very small numbers that are easily readable by humans over to some very big numbers which are hard to communicate. So that's a challenge for us to figure out how we can best translate that over to our clients. Then the first quarter of next year, of course, we'll have the performance testing done, so we can also optimize those queries in that quarter. But we're moving towards those regional web queries, so also performing improvements on those. Global locking, as I said, that's one of the challenges that we have when trying to scale EVA globally as well. Making sure that if you try and mutate an order, say for example in Japan, and it's being mutated in Amsterdam as well, we want to try and prevent that as much as possible to make sure that the order keeps the state that we expect it to. And we're also trying to migrate the other test environments as well to GigabyteDB in that quarter. And then moving onwards towards the next parts of the year, we're actually planning to migrate some of our production clients over to GigabyteDB, which is going to be very exciting. And that's it from me. That's New Black story behind EVA and GigabyteDB so far. Any questions? I'd be happy to answer.